Students, this is a short video on how to do the linear regression and find R, the correlation coefficient, A, the value before the X variable in a linear equation, and B, the constant at the end of a linear regression equation. So let's take a look. Okay, if you notice here, this is a graph of the data that we have looked at recently, and we know that there must be a line that could more or less go through this data, and we could use that line called the regression line to describe the data and to use it to predict values. So let's look at this some more. Okay, this is our data. You may remember that, and we are going to put the data in the calculator. So let's do that at this time. Okay, here's our calculator, and of course we have our number keys down here at the bottom. Remember how to do this. We have to go into the statistical feature of the calculator. So we're going to hit second stat. All right, now this time we want to select two variable data. Now that we've got that selected, we need to put our data in the calculator, and we're going to do that by hitting the data key. Now I notice that I have values in here, so that's not really a good thing. So if I will get out of the statistic editor and go back in to the editor, you will see that that's another way to clear the data. All right, anyway, years of education and then the score on that prejudice test. 12 and then 1. So our Y value is 1. The next person B, was 5 and 7. The next person C, was 14 and 2. Then 13, 3. Then 8 and 3. No, 8 and 5. Sorry about that. Then 10 and 4. 10, 4. Okay. So a next one is 16 and 1. 16 and 1. Then we have H was 11 and 2. And I was 12 and 3. Okay, the last one, which should be the 10th person, is 4 and 10. 4 for the grade level, 4th grader, and then the score was 10. Okay, so now our data is in the calculator. Now what we need to do is crunch out all of those formulas that we talked about, and without having to do that by hand, remember our key, the key to press was stat var, so I'll just press that right there. And let's go through the meaning of the numbers. N is the number of data values. That's the average grade level, statistics for the standard deviation for the grade level, the average score on the prejudice test, standard deviation for that, of course the sum of the x's, sum of the x squareds, sum of the y's, sum of the y squareds, sum of the products. Okay, remember those were used in the formula if we were going to do it by hand. But these three values are the most important. Now, notice we have A, we have B, and we have R. Let's take a little further look at those values and how we use them. Okay, so now let's take a look. I think I have a pen right here. Okay, we're going to take a look at the R value. So here we had R is equal to negative 0.92149. Let's just round that to two places. Negative 0.92. What does this tell us? This tells us that the relationship between the two variables, your grade level and the score on your prejudice attitudes or so forth, is negative. Matter of fact, it's negative strong. It's almost linear, okay? Remember, to be linear, R would have to be a negative 1. So again, that's very strong correlation. Very strong correlation. All right, now let's look at this A and the B. Now before we do that, let's just review this business about the linear relationship. Again, we're familiar with the idea of y equals mx plus b. That is the equation of a line. Okay. Now, in our case, we're going to say the y is p for prejudiced. Okay. The a, this is going to be ax plus b. Okay. So in this case, we're going to look at our a value, which was 0.686. We'll round to negative 0.69. Okay. And then plus b. In this case, b was 11.01. 11.01. Okay, we don't want to really get too bogged down with the many decimal places here on this problem. Again, this is the the equation of the line that would best fit the data. What does it mean? That's the most important thing that we need to be looking at right now. So what this means is as the years go up, 1 all the way over to 16, our value on the test goes down by 0.69 or maybe close to 0.7. So each year represents a decrease because of the negative sign of 0.7 on the test. So that's what the 0.69 means. Now the 11.01 means if x was 0, that my score would be 1101. What does 0 mean? 0 means, in theory, I don't have any education. Okay? Now, let's just say that we did not have a data item in there, like, for example, someone in the 9th grade. I wonder, given all other things equal, what the person's score would be. That's a good question. So we could do some substitution. P is equal to negative 0.69 times 9 plus 11.01. Okay? So when we just get a calculator, that's close to negative 6.3, but let me get an accurate number. 9 times 0.69 negative, 6.21. So negative, this is going to be negative, something happened to my pen here. Had it upside down. Negative 6.21 negative 6.21 plus 11.01, which would be 4.8. We could predict the score on that test as 4.8 for someone in the 9th grade. Now, this idea of a set of data, figuring out the line, and then having some equation is very important in statistics. And there's a lot of applications of that impact you every day. You may not be aware of it, but they're out there. And I hope that this particular section of our study helps you understand that a little bit better. All right, good luck, and I wish each one the best. Thank you.